Hello, dear student. My name is Shahid Mehmood. Today we will explain the Unit 1 Chemistry AS Level October 2023 paper. Question 1A. An atom of aluminium, 27 is a mass number, 13 is the atomic number, forms the ion aluminium 3 plus. What are the numbers of protons, electrons, and neutrons in this ion? So, while working out this question, we should know that aluminum, the mass number and atomic number are given. We know from here that protons are 13, electrons are 13 because they are equal, while neutron is 27 minus 13, so 14, which lost 3 electron. So it has 13 proton, 10 electron only. Option D. Question 2. What is the shape of a p orbital and the maximum number of electrons it can hold? So you know that s orbital shape is spherical, while p orbital shape is dumbbell. So here p orbital shape and then the number of electrons it can hold. So definitely either this or this is option, but the number of electrons in an orbital is 2 only, so the correct option is C. Question 3 is the formula of calcium carbide is CaC2. What is the formula of the carbide ion? So to work out this question, it's very simple. To see that compounds are neutral. Compounds are neutral. The reason is their positive and negative charges are same, are equal. So the net charge is 0. We know that calcium is in group 2. So if calcium charge is 2 plus 2 cancel the C2 charge, so C2 has the charge 2 minus, total will be 0. So here the C2 ion charge is 2 minus and the option is C. Its part B, X is calcium carbide and 10 gram of aluminium react to form the hydrocarbon ethyne. Balance equation is given. What is the mass of ethyne that forms, assuming a yield of 100%? The MR of water and ethyne is given to us. So to work out this question, first of all, we have to write the equation again. In multiple choice question, we need to quickly reach to the answer. If we read the question carefully, so X is calcium carbide and 10 gram of water. So just under water, we have to write 10 gram to form the hydrocarbon ethyne. Now, what is the mass of ethyne that forms? So ethyne is here. We will write in front of 10 gram the mass of ethyne produced from this 10 gram of water. Now, you have to keep in mind this point that if it is mass, you have to write the mass of this. Now, the mass of one H2O is 18, but this is 2 H2O, so it will be double, 36 gram. The mass, this is also mass, so we have to write the mass of C2H2, which is 26.0. Then cross multiply, so 10 times 26.0, and our option will be 7.22 grams, so option A. Question 4. Which diagram best represents the electron density map of sodium chloride? We have two types of compounds, ionic compound and covalent compound. In ionic compound, metal react with metal combines with non-metal. So in the electron density map of ionic compound, they must be separate particles, while they are enclosed in the single line. So this and this is for covalent. So here for this question, the option A or B, but like if you look at sodium ion and chloride ion, so sodium ion has only 2 shells, while chloride ion has 3 shells. So the chloride ion size will be bigger. So here the correct option is option A. Question 5. What types of bonding are present in the compound ammonium chloride? If you remember the dot in cross diagram, so nitrogen has 1, 2, 3, 4, and 5 electron. 1 is paired, 3 are unpaired. In the first case, nitrogen mutually shared 3 electrons with 3 hydrogens to make ammonia. It has lone pair. It comes in, attach or give this electron pair to hydrogen ion. So overall, it makes ammonium ion. While chloride ion has 7 electrons, but it gains 1 electron from another particle and has -1 charge. So if you look at here, this and this, these three are covalent bond. This one is dative covalent bond because the lone pair of electron has been given by nitrogen, while there is a force of attraction between the positive and negative chloride ion. So there is ionic bond as well. So here the correct option is option B. It means ionic bond, covalent bond, and dative covalent bond all are present in this compound. Question 6. The electronic configurations of the atoms of four elements are shown. What is the electronic configuration of the atom of element which has the lowest first ionization energy? Lowest ionization energy. So if you look at here, the easy way to reach to this answer, if you just total the number of electrons, so 2 plus 2, 4, 6, 10 to 12. This is 2, 2, 4, 6, 10 to 12 is 14, and here the total number of electron is 15. Now let's come to the periodic table. These are the atomic number. So these are for magnesium, then aluminum, then silicon, and then phosphorus. Now see here, they are in a series. Across the period, ionization energy is increasing, but there is a deviation over here. If you remember the graph, that aluminum is lower ionization energy. If you remember that graph, so it will help you that see here in this case, this is aluminum. So they gave you 12, 13, 14, and 15. So aluminum has the lower ionization energy. So the correct option here is option B. Question 7. A direct electrical current was passed through a green solution of copper 2 chromate 6 in the apparatus shown. The diagram is given in the student books. The same experiment is given with the green solution. Now, if you remember the formula or the name, so you must keep this in mind that copper plus 2 aqueous ion color is blue, while chromate 6 and color is yellow. When blue and yellow combines, we get green color solution. But when the solution is kept in this tube and the electricity is passed, so this copper ion will go to the negative electrode because opposite ions attract each other, while this will go to the positive electrode. And here the question becomes very simple, that they are asking to the negative electrode which color will come, and to the positive one which will come. So to the negative electrode blue color will come, while the positive electrode yellow color will come. So the correct option is option C. Question 8. In which region of a mass spectrometer are particles ionized? So if you remember the diagram, the instrumentation, P is the sample area, while Q, this is positive and negative, this is the particles are ionized. So the correct option is option B. Question 9. A sample of the element chlorine was analyzed in a mass spectrometer. Chlorine has two isotopes, and that already you know that chlorine has two isotopes, 35 and 37. So we can easily detect this in the mass spectrum. What is the total number of peaks due to the ions with a single positive charge, which could be seen in the mass spectrum? So any element having two isotopes, so we can get 3 molecular ion. So 3 molecular ion and 2 ions for the isotope. All these ions have +1 charge. So the correct option is option C. All these ions have +1 charge. Question 10. Propene reacts with hydrogen chloride to form halogenoalkanes. Which of these steps is most likely to occur in the reaction? If you look at here, so this is CH3, CHC double bond CH2. Now, to react with HCl, we have two choices. As alkene is unsymmetrical, HCl is unsymmetrical, so we will have two choices of the product, like major product and minor product. Definitely, this will be polarized as chlorine is more electronegative. The double bond pi electron will attack on the positive end. If we want to write the major product, so which has more hydrogen, so we will get CH3, CH and CH3, and the second carbon will get positive charge. It is called secondary carbocation. But if we want to write the minor product, so this hydrogen will be attached to that carbon, will become CH2, while the last carbon will get positive charge. Now we have chlorine here, which has now negative charge with the lone pair. Now in the last step, this lone pair of electron will attack here to give major product, and this will attack on this to get minor product. So look at here the question. The question they ask you is most likely. That means they are pointing towards the major product. So if you compare the two mechanisms, so the correct option is option C. And the reaction, it's part B, the reaction of propene with hydrogen chloride is an example of all alkene reaction are addition reaction. So either this or this, and they are electrophilic addition. So option D is the correct option. Ethene reacts with acidified potassium magnate 7. 4 statements about the reaction are given below. The organic product can show geometric isomerism. The type of reaction that takes place is oxidation. The bond angles around each carbon atom are greater in the product than in ethene. The acidified potassium magnate 7 decolorizes in the reaction. How many of these statements are correct? So it will be more better if you write the equation. This is ethene, and you remember that whenever it is reacting with acidified potassium magnate 7, so always the product is diol. Now, the organic product can show geometric isomerism. Geometric isomerism exists only in alkene, but there it is alkane. So the first takes place is oxidation. Yes, this is oxidation reaction. The bond angle is around each carbon atom are greater in the product than in eternal planar 120, while each carbon is bonded to 4 other atoms. So this is tetrahedral 109.5 degree. So this is smaller than that. So this statement is also wrong. The acidified potassium magnate 7 decolorizing the reaction. Yes, this is also the correct option. So our correct answer is option B. The concentrations of mixtures can be given in units of parts per million, ppm. A sample of a gaseous mixture contains 2.19% of carbon dioxide by mass. What is the concentration of carbon dioxide in ppm by mass in this sample? Look at here, we have two parts. One is mixture and one is the concentration of carbon dioxide in this mixture. They give us a clue that if the mixture is 100, so in this case, carbon dioxide is 2.19. So if the mixture is 1 million, then how much carbon dioxide will be there? So we can simply calculate 2.19 times 10 raised to the power 6 and divide by 100. And our correct option will be 2.19 times 10 raised to the power 4. Option B. Part B, a solution of lead nitrate has a concentration 15 parts per million. This is just the reverse of the previous question. Like we have solution. They are asking the concentration of lead nitrate. So see here, if the solution is 1 million, because this is 15 parts per million, so lead nitrate it will be how much? So X is equal to 15 times 400 divided by 1 million, and our correct option will be in gram. They give you the value in kilogram and gram also, so but like this is a gram, so the value is a gram, and correct option is A. Question 13. Which solution contains chloride ion concentration 0.05 moles per dm³? So this question like we can solve in different way. Like see here, one compound is given calcium chloride and one is given sodium chloride. Calcium chloride here, and first of all we have to find their MR. So this is 40 plus 71, 111, and this is 58.5. These are the MR. Now the mass of solute we will change into moles. Mass is given, we will change this into moles first. Suppose we are doing for part A, so 1.39 divided by 111, and it will change into its mole, that is 0.0125 moles. This is the mole of calcium chloride. Now, one calcium chloride gives 2 chloride ions. So this will give how much? So cross multiply. So X 0.025. So this is the number of moles of the chloride ion in the given solute. To find the concentration, N over V volume must be in dm cube, but here it is given in cm cube. So this number of mole divided by the volume n dmq. We will divide these each volume by 1000. So here we will get 0.1, which is not like that. So this is option A, which is not uh, equal to the given data. Now option B, again it is given 1.39 divided by 111, the number mole. Then it has the chloride ion 0.025 moles of chloride ions, and to calculate its concentration, this 0.025 divided by 0.5, because now here the volume is 500 and here it's per dm cube. So our correct answer is answer option B. If you don't get the correct option, then we can go for all, and then we have to compare the answers with the given data in the question. But here, by following the same procedure, we reach to the correct option, so no need to try for C and D. The formula of phosgene is COCl2. What is the total number of atoms in 9.9 gram of phosgene? In this question, where we need to calculate the number of atoms, the number of ions, we do in 3 steps. The first one, we have to find the number of moles. When it is multiplied by the Avogadro's number, then we get the number of molecules. And whenever we multiply this by the number of atoms in the given compound, so we will get the net number of atoms in that compound. See, in this case, like how to calculate the number of moles, 9.9 gram is given, divided by the mol, which is 99. So this will be the number of mole times Avogadro's number, which is given to us. So we will get here the number of molecules. The second is for the molecules. Now in each molecule, the number of atoms, COCl2, so 1 and 1, so total number of atoms are 4. So here the correct option is option D. What is the total number of structural isomers with the molecular formula C5H12? Here, the first thing which you should bring in mind that hydrogen is 12 and this is 5. So 5 times 2, 10, and hydrogen is more than its double. So it is alkane. It means there is throughout carbon-carbon single bond. Now, to save time, you can easily draw their skeletal formula. So 1, 2, 3, 4, 5, 1 isomer. Then remove 1 carbon and take it to the branch. So this is 1, 2, 3, and 4. So 2-methyl butane. Again, remove 1 more carbon and do like this. So 1, 2, 3, 2,2-dimethyl propane. So the total number of possible isomers are 3. So the correct option is option D. A cyclic hydrocarbon has a structure shown. Skeletal formula is given. How many pi and sigma bonds are present in the molecule? Here you can see the double bonds are 2, so the pi bonds are 2, either option A or B. No need to waste time on C and D. Secondly, this is skeletal formula where hydrogens are not mentioned. So this carbon is bonded with 3, like it is making 3 bonds, so there is 4th hydrogen. Here it is making 3 bonds, so 4 is hydrogen. Again, same here, same here. And here are 2 hydrogen because it is making 2 bonds. But all single bonds are sigma bonds. So see here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So this is the correct option and option A. This is easy question. So take care and quickly reach to the correct answer. Question 17. A technician is asked to store 4 reagent bottles safely. The only information about each substance is the hazard label on the bottle. It means on the bottle there is nothing written, only the labels are there. Based on the hazard labels alone, which 2 bottles should never be stored together? So you see, you must know the meaning of these signs. This is for the oxidizing agent, which helps in the burning process, oxidizing other compounds. This is highly flammable. This is corrosive and this is toxic. So this is flammable. So definitely option this or this should be. So toxic and flammable has no relation, while oxidizing agent is supporting the fire. So this is flammable. So W and X would be the correct option. Period 2 elements are given in the table and along with their first ionization energy values. The question is explain the general trend in first ionization energy across period 2. Dear students, whenever you are explaining any property across the period, either it is increasing or decreasing, you have to focus on few factors. Here, the across the period, this is very clear from the values given in the table. But the factors are number 1, as we move from lithium to neon, so the nuclear charge increases. You can say the nuclear charge increases, one factor. Now, why the nuclear charge increases? Because the number of protons increases. That's why the nuclear charge increases. But the most important thing is without an increase in shielding effect, because electron is added to the same shell. So these electrons are strongly attracted by the nucleus and needs more energy to be removed. Predict the value for the first ionization energy of oxygen. Justify your answer. Now, this question you have to think deeply. Now you have to focus that what should be the value for oxygen uh, in the second period. If you remember, so we studied before that group 1 energy is lower than group 2, but then the group 3 energy is also lower than group 2, then it increases 4, then group 5, and then group 6, then group 7, and then group 8. Like zero group, noble gases has the top or the highest first ionization energy, while the group 1 has the lowest ionization energy. The values which are given here, the elements which are given here, they are lithium, which is here, then beryllium, then boron, then carbon, then nitrogen, then oxygen, then fluorine, and then neon. Now, you can see here that oxygen value is higher than carbon, but lower than nitrogen. So to predict its value, it should be higher than carbon, but lower than nitrogen. And it should be the value you can predict, like suppose higher than this. If you look at here the 200 range is already here. So it can be like if it is 1000, it could be 1250 to 1300 kilojoule per mole. Now they're asking we have to predict and we have to justify the answer. To justify the answer, like why it is lower than this value. So if you look at an atomic number is 8, so we can do the configuration. 1 is 2, 2 is 2, 2p3, while for oxygen 1 is 2, 2 is 2, 2p4. If you draw the box configuration, so nitrogen has 1 electron in each 2p orbital, while oxygen of the p orbital. So there is electron repulsion, and it needs less energy to be removed electron from here. So you can say either the statement you can write for oxygen or for nitrogen. Both will be accepted. You can say in oxygen, there is electron pair in one of the p orbital. So there is electron repulsion, and it needs less energy to remove electron from a pair. The second ionization energy of lithium is given to us. They are asking that write the equation for the second ionization energy of lithium, include the state symbols. So we are going to write the second ionization energy for lithium. So plus 1 charge. The reason is 1 electron has been removed. We are going to remove second electron from lithium. So by removing second electron, it will get another positive charge. So this answer is also allowed, or this equal. So you can also write like lithium ion. It gives lithium 2 plus ion. If we shift this electron to this side, then you can write in this way. So either the first equation or the second equation you can write in your answer. Explain the large difference between the first and the second ionization energies of lithium. We have to explain the difference or the big difference between the first and the second ionization energy for lithium. The energy, if we do the configuration, so 1s2, 2s1. While for the second ionization energy, we have to write only 1s2. In the first ionization energy, electron is going to be removed from 2s, while the second electron is going to remove from the 1s. So when you do the configuration of lithium and lithium ion, it will be clear to you that the first electron is removed from 2s subshell, while second electron is removed from 1s subshell. Now you have to compare them. Number one, 2s has greater energy than 1s. So this electron energy will be more than this one, and it needs less energy to be removed. Secondly, you can say if there is a nucleus. So look at here, it has more shielding. 2s electron exhibit more shielding effect than 1s electron. The third thing is the second electron is removed from a positive ion which has smaller size than lithium atom, and the number of proton is more than the number of electrons. So outer electrons are strongly attracted and needs more energy to be removed. The next is beryllium react with chlorine to form beryllium chloride. In the gas phase, beryllium chloride exists both as a simple molecule BeCl2 and as a dimer Be2Cl4. Draw a dot and cross diagram of the molecule BeCl2. From the periodic table, it is very clear that beryllium is in group 2 while fluorine is in group 7. So first of all, we will draw beryllium, and it has only 2 electrons which are to be unpaired. Then chlorine has 7, so 1, 2, 3, 4. The other side 1, 2, 3, 4, 5, 6, and 7. So beryllium has 4 electrons. Chlorine has 8 and 8. So the chlorine octet is complete while beryllium has only 4 electrons in the outer shell, and it is called electron deficient compound as well. Here, explain the shape and bond angle in the molecule of BeCl2. You saw that the beryllium chloride central atom beryllium is surrounded by 2 bond pairs. So the shape is linear and the angle is 180 degree. Explanation is very simple. Beryllium is surrounded by 2 bond pairs of electrons. These pairs strongly repel each other to get maximum distance and minimum repulsion. As the repulsion will be least, it will be more stable. So the shape is linear and the angle is 180. Here, draw a diagram to show how two beryllium chloride molecules bond together to form the dimer Be2Cl4, stating the type of bond involved. We saw before that beryllium chloride shape is linear while chlorine has 3 lone pair. Their octet is complete while beryllium is electron deficient. So if we draw another beryllium chloride, because we are joining 2 now, so the other beryllium chloride, also chlorine, octet is complete while beryllium is electron deficient. So if this electron is given to this one and this electron pair is now, this is just working out. To draw its exact shape, we can draw the shape now in this way. Now, if you look at the exact bond angles, so you can see here that beryllium is surrounded now by three bond pairs. This one, and this one. So its shape is trigonal planar and the angle should be 120. Here, this beryllium also, this beryllium also is surrounded by three bond pairs and it is 120. While this chlorine and this chlorine, they have two lone pairs and two bond pairs. This is now bond pair. Two lone pairs, two bond pairs, just like exactly oxygen in water. So it is V shape. This is the inverse V shape, and the angle is 104.5 degree, and this angle is also 104.5 degree. So this is the exact shape with the exact geometry, while the bond formed between the two beryllium chloride molecule is dative covalent bond. The type of bond will be dative covalent bond. Question 19. Many cars use fuels containing ethanol as well as hydrocarbons. The E number of these fuels show the percentage by volume of ethanol in the fuel. For example, an E5 fuel contains 5% ethanol and 95% hydrocarbon by volume. It contains 5% ethanol and 95% hydrocarbon. A brand of E10 fuel contains 92.2% hydrocarbons and 7.80% ethanol by mass. The energy density is the fuel burn. The energy densities of the two components of this brand of fuel are shown. So energy density of the hydrocarbon is given to us 46.5 megajoule per kilogram, while energy density of ethanol is given 29.7 megajoule per kilogram. And question 1 is calculate the mean energy density of this E10 fuel in megajoule per kilogram. This is exactly like the way we find the relative atomic mass. This is the energy density of the hydrocarbon, but its occurrency is 92.2%, is 29.7 megajoule per kilogram, and its occurrency is 7.80%. So in this case, we can calculate that the way we calculate the relative atomic masses. So we can say that the mean energy density is equal to 46.5 times 92.2 plus 29.7 times 7.80 and divide by their percentage total, it is 100, and we will get the answer 45.190 megajoule per kilogram. To round it, 47.2 to three significant figures megajoule per kilogram. So this is the answer. The density of E10 fuel is 0.729 gram per cm cube. Calculate the mass of 1500 cm cube of the fuel. This is density, this is volume, and we are calculating mass. So D is equal to mass per unit volume. So D is equal to M is equal to D times V. So M is equal to density is 0.729 gram per cm cube, while volume is 1500 cm cube. And here the answer will be 1093.5 gram. If you want to change into kilogram, so divide by 1000 and we will get 1.0935 kilogram. This is one way. There is another way also. You can simply say here the density which is given, the density is given to us 0.729 gram per cm cube. It means if we take 1 cm cube and we burn it, its density will be 0.729 gram. Its mass will be 0.729 gram. So if we take this fuel 1500 cm cube, what will be the mass? So X is equal to 9 gram, and the answer will be 1093.5 gram, which is equal to this kilogram. So either that way or this way, you can solve this question. Calculate the energy released when 1500 cm cube of the E10 fuel is burned in excess oxygen using your answers from A1 and A2. If you did not calculate the value for the mean energy density of the E10 fuel in part AI, use a value of 38.1 megajoule per kilogram. This is not the correct value. So they just give a clue over here, but already we know this 1500 cm cube is equal to 1.0935 kilogram. The mean value, because we are supposed to use that mean value which we calculated, that was 45.2 megajoule in per kilogram. So it's very simple question. See here that if we burn 1 kilogram fuel, we are getting the value 45.2 megajoules. So right now we are going to burn 1.0935 kilogram. So how much energy will be released? And that is the energy density in this case is 1.0935 times 45.2, and our answer will be 49.415 megajoule. Part B is many countries are gradually replacing E5 fuels with E10 fuels. Explain how this change might result in a more sustainable fuel. This is a bit general question, but if you look at the start of the question, so they compare E5 and E10. So from there you will get a clue, because the E5 fuel contains 5% ethanol. This one, the E5, it contains 5% ethanol, while E10 contains 7.80% ethanol. So it means if we are replacing E5 by E10, so we are using more ethanol in our fuel. Now, you can simply say here that in E10 fuel, more ethanol is used, and ethanol can be produced from plants because it is what? It is a biofuel. Ethanol can be produced from sugar or starchy plants, or glucose, you can say, which is taken from the plants by fermentation process, which is a cheaper method. Low temperature is used, like 30 to 40 degrees Celsius, because enzyme yeast is acting as a catalyst, and there is less emission of the carbon dioxide, because like we don't need high temperature, so less fuel is used in this process. As less fuel is used in this process, so there is less emission of carbon dioxide into the air, which can cause global warming if you use that fuel. Part C is the straight chain alkane hexane can be reformed to give a range of the products. It was suggested that one such reaction may produce a cyclic hydrocarbon, and hydrogen gas is the only product. Cyclic hydrocarbon and hydrogen gas is the only products. The cyclic hydrocarbon contains a ring of 5 carbon atoms. Write the equation for this reaction using molecular formula. State symbols are not required. So this is actually, they are saying that this is reforming process, and we have to take hexane. So C6, hydrogen, we see 6 times 2, 12 plus 2, 14, and it will give now cyclic hydrocarbon, which is equivalent to alkene. So C6H12 and 1H2 will be released. So by using the molecular formula, like the equation is very simple. Whenever we change a straight chain into cyclic compound, one hydrogen is always released. The next question they're asking, they draw the structure of the cyclic hydrocarbon form in this reaction. So please read the question carefully, and you see here that they gave us the cyclic hydrocarbon contains a ring of the 5 carbon atoms. So this will guide you, and you can simply say the structure of the cyclic hydrocarbon formed in this reaction. So you can say, like, there will be 5 carbon in this chain, but there will be one CH3 bonded to it. Or you can write This is also allowed, like whenever you write this one and then CH3. Hexane will react with chlorine in the presence of ultraviolet light to form a number of products. Describe the role of ultraviolet light in the initiation step of this reaction. So this is free radical substitution reaction in hexane or in alkane. We know that UV light is used in the initiation step because there is a bond breaking. And this is very common question that when we want to break this bond, this is homolytic fission and the two bond pair of electrons comes one to each atom and we get free radicals. So this is the part of the mechanism in that. Now to explain that what is the role of the UV light in the initiation step of this reaction. So we can say that to break the chlorine-chlorine bond, energy is provided by the UV light. Because the UV light energy is more than the bond energy of chlorine-chlorine. So the bond breaks homolytically and free radicals are formed. So the bond is broken homolytically. I mean, this is homolytic fission and two chlorine-free radicals are formed. The alkane do-decane C12H26 is formed in this reaction. Write equations for the propagation step. It means one reaction for propagation step and for the termination step for the formation of this product. Use molecular formulae in your equation. So the propagation step is, we know that the chlorine free radical, which has been produced in the initiation step, it will come and it will react with the hexane. Now, chlorine free radical is highly reactive, so it will take one hydrogen by force from this hexane to form HCl. What will left over there? So C6H13 and free radical. So in free radical mechanism in the propagation step, on the reactant side, there is one species free radical, one is a molecule. On the product side, there is a molecule and a different free radical. While in the termination step, is we are supposed to make the product C12H26, which is do-decane. So we are supposed to combine only this free radical with this free radical. So you can simply write C12H26, or you can also write in this way that C6H13, they are true, and they give C12H26. This question is about alkenes. A straight chain alkene X has the structure shown. And first of all, when you see the structure, so see 1, 2, 3, 4, 5, there are 5 carbons and double bond at the second position. So this is pent 2-ene. Draw the skeletal formulae of the 4 structural isomers of X that are alkenes do not include geometric isomerisms. So see here, in the first case, we have to drop 5 carbons, as such as is given here, but just change the double bond. Now this is 1, 2, 3, 4, and 5. So this is pent 1-ene. Now we will remove one carbon from the chain. The double bond is still at one position. Now one carbon we reduce. That reduced carbon we cannot attach this and this, the terminal carbon. So we can attach to this position. So this is another isomer. Secondly, reduced from here, we can attach to different position. And now the 4 carbon chain, we will shift the double bond position. The reduced carbon we can either attach here in position. So very easily we can draw these 4 isomers. Explain why X can exist as geometric isomerism. Now you see that geometric isomerism, this is very common question. It is only happens in alkene because in alkene there is carbon-carbon double bond. So we'll say that in X there is carbon-carbon double bond which restrict the rotation. It means carbon-carbon double bond, there is no rotation over here now. Otherwise the bond will break down. And secondly, the more important one, different atoms or bonded to each carbon atom of the carbon-carbon double bond. To explain here further, if we have this situation that there is H, like this hydrogen, if same atoms are attached to one, both are one carbon, or group of atoms are attached, like suppose CH3 and CH3. Now they are same attached to this one carbon atom. So there is no geometric isomerism. Another compound Y has a structure shown. Give the IUPAC names for compound Y. So look at here. This is CH3, this is CH3. So we can number from any side 1, 2, 3, and 4. So we will see here, this is CH3. So carbon is here, carbon is here. So it is E isomer because the priority groups are on the opposite side of the carbon-carbon double bond. So first we have to write the isomer 2 dichloro. The longest chain has 4 carbon double bond, second position, and but 2 in. It is also allowed that if you write like this is trans, if they will be the same side, so it will be Z, but this is trans 1,2 dichloro but 2 in. So either this or this, both are allowed. A student stated that compound Y has polar bond, so it is polar molecule. Comment on this statement. You see here that compound Y, it has carbon-carbon double bond. This was connected to chlorine-chlorine, and this was connected to CH3C. So no doubt that it has bond is polar bond. So you can say that the carbon-chlorine bond is polar because of the different electronegativity values. And secondly, the molecule is non-polar, is it is symmetrical, but the dipoles cancel out one another. You see here that this chlorine is more electronegative, so attract electron to this side and this to this side. So both chlorine attract electron with equal force, so this side cancel this side, and overall the molecule is non-polar. Bisabulines are a group of compounds found in plants and fungi. Bisabuline molecules contain several carbon-carbon double bonds. 5.51 gram of alpha bisabuline reacted with 1873 cm³ of hydrogen gas. The reaction occurred at a temperature of 150 degrees Celsius and a pressure of 152,000 Pascal. Molecular mass is given 204. Calculate the amount in mole of alpha bisobilene in 5.51 gram. So it's a simple question because whenever we are calculating mole, so mass over molar mass. Mass is 5.51 gram divided by 204.0, and the answer is 0.027 mole. Now, here in this question, they gave the volume of hydrogen. Temperature is given 150 degrees Celsius. Pressure is given 152,000 Pascal. And we calculated the number of moles of alpha bisobuline, that is 0.027 moles. Now, the next question, calculate the amount in mole of hydrogen gas that reacted with alpha bisobuline. Use the ideal gas equation, PV is equal to nRT. This equation we will arrange first. PV is equal to nRT. We are calculating N, so N is equal to PV over RT. Now, pressure was 152,000 Pascal. We need to use this in Pascal, and it is already given in Pascal. Temperature is given to us 150 degrees Celsius. We will add to 73, and we will get 423 Kelvin. Volume is given to us 1873 cm³. Now we need to change this into meter cube. So we have to times 10 raised to power minus 6, and this will be meter cube. And the R value is already given to us. By putting all these values over here, times volume is 1873 times 10 raised to the power minus 6 meter, divided by 8.31 times temperature is 423. And we will get the answer, that is 0.080963, to round this to that one 0.081. And this is the number of moles of hydrogen gas, which completely react with the number of moles of gasoline, which we calculated before. Now reduce the number of carbon-carbon double bonds in a molecule of alpha bisobilene using your answers to C1 and C2. So look at here. If you look at like this is ene is written at the end, so we'll just say that it is alkene, and then it combined with hydrogen, and we will get the respective alkane. So the unsaturated will change into saturated. We have to find the mole ratio. Its mole was 0.027, while the hydrogen mole we calculated 0.081. This is the moles of alkene, this is the moles of hydrogen. To get the mole ratio, we will divide by the least number as we do this technique and the calculation of empirical formula. This will be cancelled, we will get 1, and this will be cancelled, we will get 3. So hydrogen will be 3 mole. So there are 3 carbon-carbon double bond in alpha bisoprolene. The repeat unit of the polymer polyisoprene is polyisoprene. It is a very simple question. Like if I draw the structure again, we have to draw here for the answer. So let me draw here. So just look at here. Now the square bracket is here and here. Now we have to draw double bond here, because when we are changing polymer to monomer, so we just remove this one, and the bracket also finish, and we directly get the monomer. This is easy question. A sample of polyisoprene has a relative molecular mass 50,250. Calculate the number of repeating units in this sample. If you look at here, this is the monomer of polyisoprene. First, we have to find its formula. So this is carbon. This is carbon, 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 carbon. So 1, 2, 3, 4, 5. So there are 5 carbon. Now hydrogen, how much? So 1, 2, 3, 4, 5, 6, 7, 8. So 8 are hydrogen. So 8 plus 8, and this will be 68. So 68 is the mass of 1 unit monomer. So we can say here now that the mass to unit ratio, it will be easier than now. If the mass is 68, it makes only 1 unit, which is monomer. So if the mass is 50,250, how many units or monomers will be there? So X is equal to 50,250 times 1 divided by 68. And our answer will be 700, which we can round to 739. Incinerator used to dispose of polymer waste have a system to remove waste gases. Suggest why these systems contain solid calcium hydroxide and finely powder. Finely powder. So calcium hydroxide, you can see from the name or formula that it is alkaline. So when we are burning polymer in the incinerator, so gases are released, and the most common gases could be sulfur dioxide, nitrogen dioxide, carbon dioxide. If there is chlorine, also hydrogen chloride also. All these are acidic, and this is alkaline. So to neutralize the acidic gases, can give one two example like SO2 and NO2 are very common present in waste gases. This is the first one because there are 2 more questions. So why calcium hydroxide is used in finely powder? So to increase the surface area, is finely powder to increase the rate of reaction. Now, this question is given, question 21. This question is about minerals containing metallic elements. The green mineral ceratite contains basic nickel 2 carbonate. Formula is given. Basic nickel 2 carbonate can be formed by the reaction of nickel 2 sulfate with sodium carbonate under alkaline conditions as shown. Atomic masses are given. The first question is calculate the relative formula mass of basic nickel 2 carbonate. So this is the basic nickel 2 carbonate. Formula is again mentioned here that the student shouldn't be confused, but it is one more question, so you will not waste that much time. This is the nickel atomic mass. So see here 58.7 times 3. Better to put in the bracket because like sometimes the student they are correct, but like they don't use calculator properly, so they lose the marks. Carbon is 1, so 12. No need of calculator here. Plus oxygen is again 3, so 16 times 3. Then plus this is OH. Oxygen is 16 and hydrogen is 1, so again plus this is 4 and H2O mass is 18, so 4 times 18. When you calculate this, so you will get 376.1. So this is the MR of the alkaline or basic nickel 2 carbonate. Calculate the atom economy by mass for the formation of basic nickel 2 carbonate of the reaction shown. So atom economy is equal to mass of the desired product divided by mass of all products times 100. Now the atom economy in this case, we can calculate the desired product. Already we calculated its MR and that was 361.1 times 100. But now to get the total product, there was 3 molecule of or 3 formula units of sodium sulfate also. When you calculate that also, I can calculate, I can write here for you. 3676.1 is the mass of the basic nickel 2 carbonate, while there was 3Na2SO4. So 3N2 142.1, the total mass will be 802.4. So we will write the mass of the all product over here, and the atom economy in this case is 46.872%, which we can round to this. The reason why use of the term relative molecular mass is not appropriate in A1, because this is molecular. We have two types of compounds, ionic and covalent. As metal is present here, like nickel, so you can say that the structure of the given compound is joint ionic structure. Ionic compounds can never be molecules. Or you can simply say the compound is ionic, they will allow it. And his joint structure, that's why. Chemists often simply full chemical equations into ionic equations by removing spectator ions. Now, give the electronic configuration of the nickel ion present in nickel 2 compounds. So if you look at here, the equation is given to us. I will write here a simple way because normally to write the ionic equation, it wastes too much time. But to write in a shortcut way, we will totally ignore the aqueous compounds. Now this is aqueous compound, aqueous compound, aqueous compound, and this is aqueous compound. So we will totally ignore it. We will not write in the ionic equation. We write only those compounds or elements which are in solid, liquid, and gas. And we write aqueous element also, which is not here. Now this compound is given in solid form. So we OH whole 4 dot 4H2O along with the state symbol. Although they write there that state symbol is not required, but anyways, we have to write no problem. And here 4H2O is left, so because it is pure liquid. So we write only those compounds on both sides, which are liquid, solid, or gas. Here is no gas present, only this is present solid, and this is present liquid. Now, we have to balance the equation now. Here, nickel are 3. So when we write, or when we are balancing nickel on the left side, we have to write its ion and the balance form in aqueous form. Here is CO3, so we have to write on the opposite side. It means left side CO3 is present on the right side. We have to write on the left side. So CO3 2 minus in aqueous. Now, if you look at here, oxygen is 4 here and 4 here 8 and here is only 4. The rest of oxygen is present here and that is in OH ion form. And you will get your ionic equation. Now, Another basic carbonate found in mineral contains the metal element X and is formed by the reaction shown. 1.995 gram of XSO4 is reacted with excess sodium carbonate forming 150 cm3 of carbon dioxide gas at RTP, room temperature pressure. Molar volume is given. Calculate the relative formula mass of XSO4. Now look here, actually here the relationship is between the XSO4 and the carbon dioxide. Now the carbon dioxide gas is produced here and the mass of this is given. So I will write here only 2XSO4 and carbon dioxide. See here, m cube. So the mass used here is 1.995 gram. Now keep in mind this is a short method. If this is the volume, we have to write the volume of this in the balance equation. If this is mass, we have to calculate the mass of this. Now here we need to calculate the mass of 2XSO4. This is volume, this is 1 mole. So the 1 mole volume is 24,000 centimeter cube. Although it is given 24 dm cube, but both must be in the same unit and cross multiply. So mass to 1.995 times 24,000 divided by 150. So it will be equal to 319.2. Now this is the mass of 2 moles of XSO4. So to find for only XSO4, we will divide this by 2 and you will get 159.6 gram per mole. This is the shortcut way. There is another way also, and that is the volume of carbon dioxide is given. First, we have to change into mole. So this volume divided by molar volume, which is 24,000 cm3. So we will get the mole of carbon dioxide, which is equal to 0.00625 moles. Now, carbon dioxide in the equation is 1, while this is 2. This is 1, this is 2. So if this is 0.00625 moles, this will be how much? This will be definitely double to that now. So we will get 0.0125 mole. This is the number of moles of XSO4. Now, this 0.0125 mole is equal to 1.995 gram mass. This. So what will be the mass of 1 mole? Cross multiply. So X is equal to 1 times 1.995 divided by 0.0125. And the answer will be 159.6. So this can be used in 3 steps like here. First, we have to find the number of moles of carbon dioxide. Then by using stoichiometric balance equation, stoichiometric ratio, this is 1, this is 2. So it will be how much? 0.0125 mole. And this mole is equal to that mass, which is given the question. So what will be the mass of 1 mole? And that is molar mass. And deduce the identity of X using your answer to C1 is 159.6. Now, the SO4 mass is 32.1 times 16 times 4. So this is 96.1 is equal to 159.6. So X is equal to 159.6 minus 96.1. X is equal to 63.5. And sure, it is copper. This you can get from the periodic table. Thank you very much, dear student. If you want to give any suggestion, so you can send direct the email or you can give in the comment box. Please subscribe the my channel so you should get the further videos. Thank you very much.